Hello guys, this is the second video tutorial, and on this video I will teach you how to translate the model to the software and get a solution. This paper was created by me to explain the basic topics about optimization models. It is a mathematical representation of a real-life problem. And the goal is to minimize cost, resource, or maximize profit. In this example that I create, Pablo is going on vacation and wants to take the maximum amount of clothing. Maximum. Okay, on that part, you know that the model will be about maximize something. Okay, but he wants to take at least 3 t-shirts and 2 shorts inside his backpack. When analyzing this situation, Pablo cannot take an infinite number of clothes because he is limited by the volumetric capacity of his backpack. The capacity of his backpack is 10 space. Each t-shirt occupies 2 space and each short 1 space. In other words, he cannot take more clothes than can fit in his backpack. Additionally, according to Pablo's requirement, he must carry a minimum quantity of certain clothing items. So he cannot take only t-shirt or only shorts. Okay, this is the model. And because this is a model with only 2 decision variables, you can do this like a hand job with a paper and pencil. Create the model like that. Parameters will be the capacity of the backpack. The decision variables is like the first decision is how quantity of the cheers Pablo will be take on his vacation, and the second will be the number of chores. The objective function is like if the optimization model want to maximize or minimize. In this case, Pablo is trying to maximize the quantity of clothing that he will put on his backpack. In this case, the objective function will be that maximize EFO, that objective function, and it is x plus y, like the number of the cheers plus the number of shorts. Okay, did have some constraints. What was the constraints? On the context of the problem, says that Pablo here he wants to take at least 3 t-shirts and 2 shorts inside his backpack. Also, Pablo cannot take an infinite number because the backpack has a capacity of 10 space, and this is additional information about how much space occupies the chair and the chart. For that, we have some constraints. The number of the chairs, x, needs to be more than 3 or equality 3 to 3. In the case of charts, y will be more than 2 or maybe equality to 2. The last one of the constraints is that the space of the backpack. We put 2 and 1 because on the context, the chairs occupies 2 space and chairs occupies 1 space. The chairs, decks, and charts is represented by the letter Y. For that, the plus of these 2 variables needs to be less than the backpack capacity. O sea, sorry, backpack capacity. And this capacity is 10 space. On this model is represented by the letter A. And the non-negativity constraint. This non-negativity constraint is related to, on this problem, on the real life, Pablo cannot use a negative number of the chair. This is not, that's not have, but sorry, this situation have no sense. Also, the number of chairs could be 0 or more than 0 because have no sense if Pablo says, okay, I will put on my backpack, I don't know, a negative number of chairs. Okay. On this paper, I did the solution because, like I say before, if you have a model with only 2 variables, you can resolve with a pencil and paper, like that. But if you have this software that I'm trying to promote, you can translate this model to the software and get a solution very quickly. Okay, first, we have some parameters. All the models will be rated on this page, the point mod page. But the real number, the real data, like for example, A is related to 10 space. The numbers will be on this page, on point data. And this page is for some option, but it is not related to this case. Okay, we need to write first the parameters. A is a float. You need to use this word. And if you write this word wrongly, if you appreciate the screen, this word is not correct. For that, don't have the blue color. But if you write this right, have the blue color. Okay, this is the parameter side. Float A equality to point semicolon. What I'm representing here, that this information will be on here. For that, if in other case I have the same model but with a capacity of 12 space, I only have to change this number and the model will be the same. For that is that. Okay. The second task, write the decision variables. Okay. Decision variables use the keyword dbar and float. This plus is to explain that the variables will be positive or 0. And the same to the second variable with the letter y. Then we need to write the objective function, and that is maximize, and the function maximize is the keyword, and x plus y. Oh, okay. I forget that, but every time that you wrote a line code, you need to end this line with this, because if you don't that, you will have some trouble. Then the subject to or the constraint, because this objective function have some constraints, and this constraint is related that you don't have this space. For example, if you don't have any constraint, the maximize will be the infinity on this page. Like if you don't find these constraints, this will be like, okay, this is not the maximum. For that, I will go to there, but it is not possible because we have this constraint and this and this. Oh, sorry. Okay. Finally, we write the constraint. This, like that, like that, like that, and here. Okay. Now we have finished the model, and we have to get a solution. You need to rename this file because have a not a forbidden letter. Maybe you need to remove this O and put this O, like, or maybe write other word like configuration. Okay, then right click and run this, and what a solution with objective is 7. And if we look the paper, is 7 too. Also, this model brings to us that Pablo need to put 3 y's through 3 teachers and 4 shorts. It's like that how I resolve on the paper. Okay, this is the finalization of this video, and this was the first model to know something about the parameters, the decision variables, the objective function, and the constraint. Also, how function the point that page. Okay, that's it. Goodbye.